Okay, so yesterday we had a look at Packet Tracer, and Packet Tracer is a simulator. It's a piece of software that everyone, it's free, and it's very useful for getting used to the initial commands on CISCO, but it doesn't really do much in terms of. It's just that, like, it'll only bring you so far in terms of in terms of your CISCO studies. You can actually, it's fine for your CCNA, but if you really want to get used to the grinds of actually networking and looking into packets and stuff like that, well, then GNS really is, is needed. Now the caveat with GNS is that it is CPU intensive, so you need to have at least minimum 8 gig of RAM, and maybe an i5 Dell processor or an Intel i5 processor or an i7. Solid state drive is also helps as well. I've seen systems with minimum RAM, minimum CPU, and a good solid state drive, and it makes such a difference, because think about what a drive does. It reads, it reads sectors on a disk, and it writes sectors on the disk. So the mechanical disk has moving parts, and the time it takes to actually write sectors on the mechanical disk, because it's spinning around and around and around, and takes a while, takes longer. But with a solid state drive, it's all chip. It's all just onto a chip, so it's much faster. So really, in order to have GNS, it's always good to get a solid state drive, get minimum 8 gig of RAM, and a good processor, Intel i7 or will make a difference on it. So let me just grab where you download it from. So you can go to GNS3 download. GNS3 download here, software. Now it is free, okay? It is free. So the ones that you want obviously use Windows, so you can click on download. Now you're going to have to sign in. If you've never signed in, you have to create an account, okay? So I have already an account created. Let's see if I can log in here. Okay, so you can download it there. So this is the latest version, 2.2.29. Now there's two caveats with GNS. One of the things, so you download it and you install it. Now there is documentation to help you set it up. Very useful to have. Okay, I have it already downloaded on it here. So you can click on the setup wizard. So if you're just getting used to GNS, right, I would just set it up here. Use the setup wizard to download it to a local server on your system. Okay. So let me just put this in here as well. So you need to download the file. You got a YouTube video as well that shows you what to do. But notice you can do a lot more with this if you have a GNS VM. But the problem with that is it's complex and it takes a lot of work to do on it. So, but you get switching with GNS just on the local wizard here with a local server. You're just really going to get routing. Okay, but I would recommend it for you to just to get used to it. I would download it and just have the basics on it, just to get used to your commands. But it goes through the whole lot. So here, what you do is you download it. The screen is really good on this. So let me actually just show it here. Right, you download it, you install it. Installation is pretty easy. Okay, you get something like this. Now I'll leave that there. So if you want to, once you come in, you click on it here, and you're going to get a setup wizard. So this is what you're going to see first. Okay, you see that there? So you've got your options here. So run appliances on in a virtual machine, you need to get GNS VM. I would hold off on doing that until you get used to it after a couple of months or a couple of weeks even. So what I would do is I'd install it here, run appliances on my local computer, okay? And you can download, and so you need, in order to get that, you need a Cisco IOS router, or like a 7200. So Cisco have these 7200 routers. What GNS is basically, you have the power of a Cisco router on your desktop. Whatever commands you can do on a real live 7200 routers, when these came out, they were like 10 grand back in the day. But you could actually run a 7200 router on your own laptop using GNS, and it'll take all the commands. Really, really useful for routing. So if you choose this option here, run appliances on my local computer, click next. Just leave the default settings there. Click next. Now, I really don't want to do this here at the moment because I have took a while to get this set up. Server, okay, so I'm just going to cancel this here, okay? So when you do that, so when you install it, you will need to get an operating system for a router, okay? Where you get that is Edit, Preferences, iOS routers, and you see here, this is the 7200. So you need to get an image, an operating system for a 7200 router. Now I have some, I'm going to upload one to Dropbox so you can use it. So if you want to get it, you click on New, run this iOS router on my local computer. Yeah, you choose that option. Don't use a GNS VM. Click Next, and then you need to take the image and you need to browse it too. So let's say new image. So you need to, wherever you saved your image to, better off creating a folder on GNS3 and calling it images in there and saving it in there. So you can see here, this is the image here. What I'm going to do here is I'm going to copy this guy here. What I'll do is I'm going to upload it to Dropbox. Actually, there might be one already in there. Pablo, sorry, I'm only get you. What, you don't have this option? You might be on mute there, Pablo.
Oh, sorry. Yeah, you say our device, right?
Yeah, I would recommend try and do it. It'll take a while to figure it out. So I would recommend try and do it after the class, because this is just a really kind of just a quick sort of tutorial on it. So what's empty here for you?
So I did click in iOS routers, but it's empty. I don't have this option.
Yes, you don't have any at the moment. That's because I have uploaded on my GNS. You won't.
Okay.
So
sorry.
what I'm going to do is you will need to get this image here, 7200 advanced IP services, and I will upload this image onto the Dropbox. If there's one not already on it, it might be, and then you can download this image onto your local PC, then click on New, click on Run this iOS router on my local computer, click on Next, and then choose New Image, browse to where you have the image. Oh, cool, thanks, Mark. The image is already in the GNS3 folder. Okay, so that's great. And is it the 7200 image, Mark? Perfect. Okay, so you download that, save it to a folder in the GNS, a subfolder in GNS3. You click on it, you browse to it, and you extract the image. And it's just next after that then. Once you're finished doing that, you will have, continue with 7, yes, a router here. So now I have a router R1, and I have a switch. This, you're not going to have this switch here, S1, because this is, I'm running, you can see it down here, GNS VM. I'm running a VM, but I'm not going to, because I would stay away from running a VM until you get used to GNS. Have a couple of weeks or a month even of getting used to GNS, getting used to how it works before even going near a VM, because it's a lot more complex. And I've worked with students before, and very few of them will get it. So you're better off just getting used to it for a couple of weeks first. Any questions on that? Okay. Now I'm not going to use this router as a router. What I'm going to use is I am going to use it as a PC, because what I want to show here today is I want to show you Telnet and the problems that we have with Telnet, and I want to look at our new option, which is SSH. Okay, so I'm going to change this router into a PC, so it operates as a PC. And the reason why I want to do that is because I want to show you Telnet, and the PC here is the Telnet system isn't very useful. So I'm going to use router here. I can configure this router to act and behave as a PC, except I'll have a command prompt. So I'm going to go into change symbol. I'm going to give it red and user. So I have a user here, R1, okay. Even though it's a router, but they're going to change it to a PC. What I'm going to do is start this up here. Cool. And I have a switch. So while that's starting up, let me just log on to my switch. So if I want to access my switch in GNS, I can right click here and go into console. And this will open up PuTTY. Talked about PuTTY. So when you install GNS, you get a free PuTTY on your local PC. You see here. So this is the same as an actual switch. This will behave as a real switch, a real iOS, a layer 3 switch, not even a layer 2 switch, a layer 3 switch, which is basically a switch that can perform routing as well. Like if I do this, enable and show question mark. Let's see how much commands this has available to us. Look at this. You need to know all these commands for your CCNA. I'm just joking. Joking. You don't need to know. You don't need to know a fraction of those commands. So yeah, don't get worried. Don't be getting worried. All right. So let's have a look at our interfaces. Show IP in brief. We looked at this yesterday. So we can see how it has lots of ports, all gigabit ports. Gigabit ports, yeah. So what we're going to do is I'm going to click my router into gig 0/0, yeah. So go back to my router here. I'm going to get a cable. So gig 0/0 to gig 0/0 on here. Now I've connected to my switch. I want to connect to my router as well. Okay, so let me just console in here. So my router is called R1. My switch is called switch. So I'm going to change my router to a fixed space T. I can say Tom. So the command is hostname space Tom's PC. Oh, Tom's PC. Okay, I'm really configuring it as a router here. Remember yesterday, one of the commands that didn't work for us was banner. Remember, it doesn't work on packet tracer banner login. You can do here banner space login. You can create a login. So you say banner login, and then you can do it limiting character. And what is the message that you want to see when people connect into your router? This is actually banner login. Enter. Oh, the limiting character. This is Tom's PC. Please stay away. And then you finish with the same character that's used to start, and then press enter. So there's my banner then. So let's see if this works. Exit out, exit out. Oh, didn't work. Show banner. Should have came up with a banner. Okay.
You're missing one. I think you're missing one character. You only had one. You only had one asterisk.
Did I show run? I should have banner there. Let's see. Oh, there it is. There's the start. There's the end. So, yeah, disable. Maybe begin on GNS, the banner function isn't there. Not to worry, it doesn't matter. Okay, so this is the router. This is the switch. What I'll do is I'm going to have these over here. So I'm going to change this to Tom. Oh, can't do that. Okay, because the router is already there. So I'll just leave it. Actually, let's see if we can just change to Tom. No. Okay, because I can't change the name here as when the router is powered on, you can see here. Okay, not to worry. So we'll have this, we'll have the switch, and we'll have the router. Okay, so what I'm going to do is I'm going to give the switch an IP address, a management IP address. So where do you give the switch a management IP address? Well, I'm going to give it 192.168.1.1. Okay. Management IP address. And Tom is going to be 192.168.1.5. Okay. So how do you give the switch management IP address? Config space T.
Config.
IP interface VLAN
1.
Enter. IP address 192.168.1.1, 255.255.255.0. Too many 255s. 192.168.1.1, 255.255.255.0. Now let's go back to the router. Okay. Now obviously this isn't a real this is not a real PC. So I need to do a few things here to turn it into a PC. In order to turn it into a PC, I need to remove the routing functionality. Do not worry about these commands, okay? These commands are not part of the CCNA per se. They're just here for me to break the rules by turning this router into a PC. So I'm going to remove the routing functionality by typing no IP route. No IP routing. There we go. Okay, no IP routing. So I've removed it now. It's not going to perform any routing functionalities. So I need to give this an IP address. Again, I would spend weeks talking about how routers route, and we're going to be doing lots of labs on it as well. But if you want to assign an IP address on a PC, how do you do it? You go into the interface, like if this Windows. If I want to assign an IP address on a Windows PC, I go into network connections and I go in to the NIC here and click on properties, excuse me, and go in to IPv4 and properties, and I can manually or automatically. By the way, obviously most devices are always set to obtain an IP address automatically. They do that using DHCP. I could manually set it here. I'm not going to manually set an IP address on my laptop. Why? Because if I did, I would disable my internet connection and the Zoom call would end very abruptly. So we're not going to do that. But you set an IP address on the interface that you're managing. It's the same here. This is going to be disconnected to gig 0/0. So I'm going to set an IP address on interface gig 0/0 on my router. Remember with the switch, you don't do it on an interface. You set an IP address on interface VLAN 1, not on a router. On a router, you set the IP address on the interface int gig 0/0 of where the PC is connected to. So it's here, interface gig 0/0, IP address 192.168.1.5.255.255.255.0. Now I need to do a no shutdown because by default, all router ports are shut down by default. You'll see that when we start looking at routers and routing. Okay, so I should be able to ping. Look what's happening. A duplex mismatch. I'm getting a duplex mismatch. I'm getting a message from on my device here, on my router, because this is a real device. Okay, what's it saying? It's saying that there's a duplex mismatch on gig 0/0 with the switch. So this port here, gig 0/0, is set to full duplex, but my switch is set to half duplex. Okay, so duplex, what is duplex? Duplex is how data flows on the interface. So duplex refers to how information will flow on the interface. Half duplex, information can only be transmitted or received at any given time. Okay, if you have a look, for example, like a walkie-talkie, that's half duplex. Each person must, with a walkie-talkie, each person must push a button to talk, and while talking, that person cannot. You can either talk or you can listen, but you can't talk at the same time. Okay, so what we need to do is, that's a problem because it's saying here on the switch's end is that the switch gig 0/0 is set to half duplex. So Cisco have a feature, and I don't like this feature on Cisco. It's called auto negotiation, right? And auto negotiation is a protocol that runs between this router and the switch, and it's a signaling mechanism. So what the two devices will do, it will choose their transmission information, their parameters, such as the speed and the duplex, automatically. Now, I don't like devices doing that automatically because it's such an important thing. So it's always a good idea to turn off auto negotiation and hard code your really important network links. Which if this was a router and this was a switch, I would want to manually set that to full duplex on this end and full duplex on the switch's end. So at the moment, it's saying that, let me just take a screenshot of this. The moment it's saying that the switch here is half duplex, while this interface here is full. That's going to lead to a problem because the router here thinks that it can send and receive at the same time, while the switch can't. And you're going to have dropped packets, okay? So what we need to do is we need to what? We need to go into the switch and we need to change that from half to full, okay? And what we need to probably need to do as well is remove this auto negotiation feature, which is a feature, auto negotiation. The way I remember auto negotiate, you ought to not use it, okay? Ought to not use it, I don't know. Whatever helps you remember these things. Okay, so we need to go in to switch, and I need to set into, and just look, it's the switch is giving us the same error. CDP. CDP is a messaging service that happens between the router and the switch. I'm going to talk about CDP. And CDP, it's CDP, which is called Cisco Discovery Protocol, that is giving us this information. The CDP is saying, hey, Lee, wake up. Look, we're having a duplex mismatch. There's a duplex mismatch discovered on gig 0/0, not full. That's the switch. Let me just write that in. This is half duplex. And our interface over here is full duplex. This is what's known as a duplex mismatch. Okay. What will happen? That will lead to packet drops. So what was the best option? Go into the switch and change the switch to full duplex. And this will keep happening again and again and again and again. So I need to go in here and I need to go into the interface gig 0/0. And I say duplex space auto full or half. So we say full. Remember I was saying auto negotiation. So it won't even set you, it won't even set. It won't let you set it. Okay, because this bloody auto negotiation is enabled. I don't like it when my devices have too much power. I like to be in control of how I manually set important information, such as the speed and the duplex modes of the NICs. Okay, so how to turn it? You say no, negotiation auto. Turn that off. And now I'll go back in and I'll say duplex space full. Guys, don't worry about a lot of these commands. I'm kind of going over this here, what's important, because we will be going over this in more detail. We'll start looking at routing stuff. Okay, so now we won't get these messages anymore. Why? Because we got full duplex on this end and full duplex on the here. If you want to see the parameters of your interface, show int gig 0/0. And you can see some information here. So you can see here, this is up. It's got your MAC address. It's got your bandwidth, which is a gigabit. It's got delay. We're going to be looking at a lot of these reliabilities. And you hear, look, full duplex. Okay, cool. It has the information incoming in bits and the information going out. Input rate and the output rate. Okay. So cool. Let me just, where are we going? Oh yeah. So if I do show IP int brief, really useful command. We looked at that yesterday. Interface VLAN 1. What's the problem here? Problem is our interface VLAN 1
It's down.
Is administratively down. That's bad. We need to bring it up. Let's see, can I ping 192.168.1.1 here? Ping 192.168.1.1. When you ping a device, you get ... That means it's not good. That's failing. So I sent 5 ICMP echo request messages, 1, 2, 3, 4, 5, and none of them got through. The reason why is administratively down. So let me do a no shutdown on interface VLAN 1. Config T int VLAN 1. No shutdown. Okay, that comes up. And all right, let's see if I do this. Okay, so I'll rerun that ping. Ping 192.168.1.1. Now, look, success rate. What I can also do is I can show you this ping. This is what GNS will do. I can right click on this guy and do start capture. So I can use Wireshark. I can incorporate Wireshark into my GNS to look at, to view all packets happening, all conversations going between my router, or in this case, Tom's PC, and the switch. And you can see it's already doing some information. So let me go back here and rerun that ping. Ping 192.168.1.1. You can see 5 there. Go in here. Look. You can see the full conversation. I'm sending an echo message. So it has all the information. So look at it. Look, this is the information of the OSI model. This is your data. What I'm sending a ping, ICMP, Internet Control Messaging Protocol, which is the actual protocol that is for ping. I'm sending an echo message, echo request, echo. I've got a checksum. Checksum is used to ensure that the packet isn't corrupt. So it runs a value test. It's like it's a quality control. Okay, this is the size of the data. 72 bytes. So I'm sending this echo message. This is like the envelope, the information within the envelope. Okay, you have my source IP address 192.168.1.5, destination IP address 192.168.1.1, source MAC address. So there's your layer 3 information. We've got your TTL. I'm going to talk about all of this stuff. Diff serve, that's for quality of service. Flags, checksum again. And you got your MAC. Source MAC. This guy here. Destination MAC. This guy. Okay. And then here's your ones and zeros. That's actually going over the interface. Okay. And you can see the response back. How long did it take for 1.1 to respond back? Like 0.6 of a second or something like that. So Wireshark is really, really good. So you can see the full conversation. Echo request, echo reply, the next ping, echo request, the response, echo reply. And it matches the two of them together. Echo request, echo reply, echo request, echo reply, echo request. So it sends 5 pings. 1, 2, 3, 4, 5. Okay. Okay, so I'll leave that Wireshark running in the background. Look at the amount of information happening here. This is your CDP. This is the protocol that told us about the duplex mismatch. I will talk about CDP in a couple of weeks' time. Okay. So I'll leave that running in the background. What do I want to do? I just said I've just sent a ping. I want to be able to telnet into my switch over here. Okay. So can I telnet now? If I can ping my router, if I can ping from R1, sorry, Tom's PC to the switch, will I be able to telnet to the switch? Telnet 192.168.1.1.
Yeah, you will be.
Okay. If I can ping it, can I telnet?
Yeah.
No. Why not? Well,
No password set.
password required, but none set. So basically, the switch is saying, you won't be able to remotely connect to a switch, because that's exactly what Telnet is. Telnet is a tool to remotely connect and remotely manage and administer a device, but you won't have that functionality unless you set a pre-configured Telnet password. You have to set a pre-configured Telnet password on the switch. Okay, so is that okay? We talked about that yesterday. So config space T, where do you set it? You set it on your line VTY 0 space 4. And anything I type in here is only going to affect my Telnet access. So if I want to give a password, a Telnet password, I say password space Telnet PW. What else do I need to do?
Lee, sorry, could I ask a question?
Sure.
You said the way you're typing line VTY 0 space 4, and yesterday we typed in 0 space 15.
Yes.
Why is this 4?
Okay, because you only want to configure 0 space 4 is I'm configuring for 5 concurrent Telnet connections. So the first connection is going to go on 0. The second will be on 1. The third will be on 2. The fourth will be on 3. The fifth will be on 4. So it can be. I normally will restrict my connections to 5. I don't want a lot of remote people connecting into my switch at the same time. I can restrict it to 1. I can put a password in here, so only 1 connection will happen. And then it would be line VTY space 0. Okay, yesterday I set it up so 16 people will connect in. VTY 0 to 15 is 16 concurrent connections. 0 to 4 is 5 concurrent connections. It's a little bit confusing. Just the way Cisco set it up. Is that okay, Edmund?
Yes.
Okay. So password space Telnet PW. What else do we need to do? We need to enable login. Okay, so we'll check that out now. So line VTY 0 space 4 password Telnet PW. What I'm going to do as well is I'm going to enable create and enable password. So enable even password enable PW. Okay. Let me go in here. Let's try again. Telnet 192.168.1.1. Enter. Now it's open here. Now it's asking me for my password. My password is Telnet PW. TELNET PW. Huh? There we go. Enable. ENABLE PW. I'm onto my switch. I have a remote connection. Let's hear. So I'm connecting from my PC / router from this guy here. I have a Telnet connection opened up to 192.168.1.10. Sorry, 1.1. So I'm on here and I've said Telnet. 1 second. One 192.168.1.1. Okay, so the thing about Telnet is, right, as I'm typing commands in, so let's say I'm type show start, show space run. So what happens? These characters are converted into 1s and 0s and are sent down this link. in the form of electrical signals. Everything you do online, we talked about this on the first day, everything you do online is converted into ones and zeros, whether it's looking at movies, whether it's using Facebook or using Skype or using Zoom. It's all ones and zeros, electrical currents, electrical bits moving down the signal. So this command here, show run, I'm typing it here on the router or on the router / PC, and that gets converted into ones and zeros. It's the ones and zeros that will go across the link onto the switch, and then the switch has to reverse engineer. It has to take these ones and zeros, and it has to produce meaningful data, which in this case will be show space run. Does that make sense? But the problem with this is that you can have Wireshark running, listening in and taking these ones and zeros and making sense of what they mean. Because the ones and zeros that go across the telnet ones and zeros are not encrypted. They're completely in clear text. So if you happen to have a hacker listening in using Wireshark, he would be able to find out exactly the full conversation or one is happening between the switch. Label listen in on the full conversation. So let me show you. Okay. All right, okay, so here we go. Okay, so I'm in here. I'm still doing the Wireshark. Yeah. So it's still listening. And you can see it's capturing information. So what I'm going to do is go back here. I'm going to start typing it in. So I'll say, hello, switch. My password is 10SPW. Okay, go back to Wireshark. You can see all the packets coming in. As you see, this is telnet. So it's picking up the conversation between who? 1.1 and 1.5. So I can just click on one of this, right click, go to follow, TCP stream, and I can put it into an actual stream, conversation. So I want a conversation here between 1.5 and 1.1. And you can see it, there we go. Telnet PW, enable PW. Hello, switch, my password is telnet. And I can have it the other way around. Look, full conversation is in clear text. So that there is a security hazard right there. Okay. Obviously, you don't want that to happen. You want to prevent that from happening. So what do? Well, you don't use telnet, you use SSH. Okay. So what I'm going to talk about is setting up SSH. So SSH stands for secure shell. It encrypts the information that happens. While telnet is clear text, SSH is encrypted. Okay, so let me set up SSH. On the router and here, I'm going to set up the router to use SSH. So I'll exit out. Oh, actually, sorry, I'm setting it up. Sorry, I'm setting it up on this switch here. Setting up this switch here to use SSH. Okay. So there's a few different things that we can do. And by the way, this actual lab, you can practice in Packet Tracer. If you don't have GNS set up, you can practice in Packet Tracer. We won't have time to do it today, but that'll be homework for you. Okay, so let me go into the switch, config space T. First thing you need to do, you need to give yourself a host name. Okay, you need to give the switch a host name, any host name space S1. And the reason why you have to give it a host name is because in a few minutes you're going to be creating crypto keys. Okay, and these crypto keys will have a name, and the name of the crypto keys is your host name and your domain name. So we've given the host name, change the host name from switch to S1. The next thing we need to do is give our switch a domain name. Domain name can be any word at all. It's just a name in which we need to create our crypto keys. IP, domain name, Brexit. There we go. Anything. So when we create our crypto keys, the name of our crypto keys is going to be S1.Brexit, switch1.Brexit, or S1.Brexit. Okay. If you don't do this, you have to do it. You won't be able to set up SSH unless you have a host name that is not switch. It can't be the default. It has to be something other than switch, and a domain name. Okay. So what we're going to do also is we're going to create or set up authentication. And authentication means I am who I claim to be. So just take that for a second there. Let's say this is Tom here, yeah? Where are you? Tom is here. And Tom is telling access. Or Tom, let's say Tom is working in IT. Okay. And we got Joe, who's also working in IT. And he has a connection to switch. And we got Al, who also works in IT, and he's got a connection to switch. And we got Sue, who works in IT, and she has a connection to switch. So we have all these people who work in IT, and they've all got connections to the switch. And let's say we don't have any username and password. We just have this generic password of PACC or PASSW0RD. Very strong password there. Nobody's going to get that. Password with W0RD. Okay. What happens if Joe, telnets or SSHs or Al connects to the switch using this generic name of password and breaks the switch? Does Joe need to put up his hand and say it was him? No. Why? Because we no way of knowing who it was, whether it's Tom or Joe or Al or Sue, because they're all using the same generic password. So what you should do is set up authentication. And authentication it basically means I am who I claim to be. So we'll have a username of Tom and a password specific to Tom. Username of Joe and a password specific to Joe. Username of Al and a password specific to Al, etc., etc. So when Joe connects in, Joe's password is going to be, let's say, Joe PW. And if he breaks something, we can then, there's a log to say, hey, switch, the user, Joe and his password connected in at 11 o'clock at night, and then the switch went down. We now we can sack Joe. Okay. So we need to create a user on the switch. Username, Tom, password, Tom Peter. Setting this up in the switch. Okay. The next thing we need to do is create our crypto keys, our SSH keys. So the command to do that is crypto key generate RSA. So it says, the name of the key is going to be S1 Brexit. This is why we changed our host name and our domain name. How many bits? What size strength encryption do you want? If we could go as far as not 4096, but it'll take a long time to produce. So we'll just go with the default. 512. Okay, that's done. One more thing. There is no point in us going through all the difficulties of setting up SSH and then leaving Telnet on. We need to disable Telnet. How do you disable Telnet? Where do you need to disable? So what ports do you need to go in order to configure Telnet? What was our line?
VTY.
VTY, very good. 0 space 4. In here, we can disable Telnet. So we can say transport input SSH. That command is saying only use SSH as your preferred method of connecting in. I could say transport input at Telnet, and that will use both SSH and Telnet. I don't want Telnet, so I'm just going to say transport input SSH. Does that make sense? This says only use SSH. Okay. Right. That's it, I believe. Let me, oh no, one more thing. Login local. So this says, people should be able to connect in locally into the switch. Okay, so let's go back to a router. Now the command here is different. The SSH command is different. So it's SSH space -L space my username, which is Tom, space IP address, which is 192.168.1.1. So the command is you SSH space -L space the username. All of this information gets put in the first packet. SSH -L space Tom 192.168.1.1. Now it's asking me for Tom's password, which was TomPW. TOMPW. And I'm in. So I say enable. And my enable password is ENABLEPW. Just taking a while. Wow, that's taking a long time. While it's there, we should still be able to view our SSH information coming across Packet Tracer. So let me just close out of that and see if we can see SSH information. Telnet uses port 23. SSH uses port 22. So you can see here, source port, destination port, port 23, whereas Telnet uses, or SSH uses 22. Here we go. You can see here encrypted packets. So I'm going to right click on this, follow TCP stream, and this is what you see. See? So if somebody tried to hack into the system, that's what they're going to see. Can't see anything. It's all encrypted. Does that make sense? Let's see if we go back here. Oh, enable. Just very slow. ENABLEPW. But you can see here. So that is why you should never use Telnet in live production environments. Always use SSH. Just
SSH stands for secure shell.
secure shell. Yeah, it does indeed. Yeah. Yeah.
Okay, good.
It's the same thing. Like if you're going online, right? Let's say, for example, let me just close all this stuff here. Whereas this GNS is actually, it's quite CPU intensive, so it was doing well to have the GNS and the Zoom call going at the same time. Sometimes it can affect the Zoom call. Like if we go in here and I type in Amazon, I say the journal.ie. So even the journal.ie, look, HTTPS. See? So everything now is HTTPS. Years ago, you know, it would only be it would only be sites that would be selling you stuff that would be HTTPS that would be encrypted. But now all websites typically are encrypted. In fact, Google will penalize websites if they don't use the HTTPS protocol, if they don't have an encryption key here created, verified by Amazon. So the journal.ie is hosted on AWS servers, I would assume, if it's verified by Amazon. Okay. So that's it for this evening. Yeah, there's GNS. It's really good to just good to get used to it. Any questions on that, guys?
No, all good.
Cool.
Well, next Tuesday, do we do subnetting or are we going to continue?
Next
on
Tuesday is subnetting. Yeah.
Okay.
Next Tuesday is subnetting. Have, if you can, have a pen and paper in advance, because you will be doing math.
Sorry, Lee. Do you have to set SSH up in every single switch on the network?
If you've a lot of switches, you have to, you can use what's known as a TACAC server or a radius server. So if you've got 50 switches, then you should basically configure a TACAC server or a radius server to manage all those devices centrally, or radius server. So that means, you know, it gives you much more functionality. We will be setting up radius in a couple of weeks' time.
Okay, thank you.
Because if you think about it, let's say you have 20 switches, right, in your network, and 20 routers, and you have 3 network staff. So 20 routers, 20 switches is 40 devices, and 3 network staff, 40 devices by 3 is 120 entries. That's crazy. You know, so what Radius will do is you create all your users, or your 3 users and your details on this one Radius server, and then the switches and the routers will contact the Radius server for authentication. So it's a centralized management server, I suppose. Pablo, yeah, just have a pen and paper handy next week, because we're looking at subnetting, because you might have to do some maths, different types of conversion from binary into decimal, from decimal into binary, so forth.
Sorry, Dee, you know, regarding the recordings, when I went on the Dropbox, all the videos are only 1 hour. Or is
Oh, yes. So when you're, yeah, and let me just pause the recording here. 1 sec.